I'm Fabio Sasahara. Welcome to this What's New in the Highway Capacity Manual 7th edition series. And for this video, we'll be talking about this new network method that's part of the new HCM 7, included in chapter 38. That's a whole new methodology that was developed by research in CHP project 15-57. And why is this research developed? The main idea is to analyze corridors that are comprised by freeways and streets. So if you look at this figure, for example, if you want to analyze a trip between points A and B, this trip goes through multiple facilities. You start with some streets. At some point, you travel through a diamond interchange. You travel through a freeway facility, a couple of segments, and then you leave through another interchange, and then you go to another street. So if we try to do this using the methods in HCM 6th edition, we would face a series of challenges. For example, how do we put all these methods together? They have different methodologies with different performance measures. And also we have the problem of interaction between these two facilities, especially when you have congestion, if queues back up from freeways to streets and vice versa. We don't have the methods in the HCM 6th edition to analyze them, so we would have to refer to micro-simulation, for example, and these are some of the limitations that we overcame with this new methodology. So, for example, if we analyze a network such as this one, again, from point A to point F, so we would travel through a couple of street segments, and then we would take an on-ramp and enter the I-10 freeway here. So that's represented here. So what are the challenges that we will be facing? So first of all, they have different measures. So streets, we measure them as travel speed when we analyze freeways based on density, for example. So this new methodology, the first thing it does is it brings everything to travel time, so we can have a common performance measure to analyze all segments in the same basis. Also, we don't have methods to evaluate congestion when it propagates. For example, if the queue backs up from the freeway or from the street to the freeway. Now we have the methods to do that. Also, this new methodology is strongly based on OD, origin destination. Depending on the origin destination that you have, that can affect, for example, your choice of lanes in the freeways. Depending whether you're expecting to enter the freeway at a certain point or leaving the freeway at a certain point, you're more likely to select the rightmost or the leftmost lanes in the freeway. And we know certain lanes are faster than the others, so that can also affect travel time, and that's what this methodology accounts for. So let's talk about queue spillback, which is one of the major parts of this methodology. And we can start first with queue spillback between freeways to urban streets. So what we see here is what happens in on-ramp queue spillback. So in this case, the queue can back up from an on-ramp into the intersection and can negatively affect intersection performance. And queue spillback may occur due to insufficient capacity at one of the 3 points that we are seeing here. So A, when we're talking about the freeway merge, if we have a congested freeway, vehicles will not be able to enter the freeway traffic and queue is going to propagate. We can also have a capacity bottleneck at B if we have, for example, a RAM meter that's present and is restricting the flow of vehicles into the freeway. So that's another common source for queues. And less common source, but we can also check for them, is the entrance to the ramp roadway. We also have capacity checks. It can also be a source of congestion. And if one of these 3 conditions occur, that's not enough of a condition to say that we have queue spillback, because the second condition that's needed is the resulting queue from that case must be larger than what is the available storage. So basically, the length between the merge point and the entrance of the ramp, it must be shorter than the expected queue length. And when you have those 2 conditions, then we know queue spillback is going to occur. And we have the checks in place in this methodology to account for that. Inputs that are required here for our analysis, we do everything based on the existing inputs that we already use for freeway facilities and for the corresponding intersection, in this case, signal. Other things that we need in the new methodology is what is the storage length, or basically the length of the on-ramp between the entrance and the merge point. And since we can also analyze the presence of ramp metering, we can also enter what's going to be the ramp metering rate, which will be a limiting factor to ramp capacity in that case. Now let's go to the other way around when we have queue spillback at freeway off-ramps. So in this case, what we're talking about here is we typically have a bottleneck, or at some point we have insufficient capacity. It can be at the exit of the off-ramp, but most commonly it happens at a downstream intersection at the end of the off-ramp, and queues may back up into the freeway. So how it typically happens is when you're very close to the off-ramp, queue is concentrated on the right side of the freeway. But as you start to move further away from the off-ramp, the queue starts to propagate further across all lanes in the freeway. Eventually, at some point distant from the off-ramp, you may find some complete gridlock, so that affects the entire traffic of the freeway. How it's modeled in the new methodology, as you can see here at the bottom, we have two adjustment factors. One of them is what we call adjustment in the queue influence area. What research has found is that when drivers are approaching the back of the queue and they realize there's a queue, they quickly adjust their position. So drivers that intend to leave the off-ramp, they quickly move to the right to join the back of the queue, while drivers that intend to travel through the segment, they quickly move to the left to avoid the queue, and that creates additional congestion, turbulence that affects capacity. The second adjustment factor that is modeled here is what we call this friction factor. So when drivers are traveling parallel to a queue, there is a little bit of friction, so drivers are more careful and reduce their speeds. So that results in a minor loss of capacity, and these two factors are modeled together in this new methodology. Another new feature that we have in Chapter 38 is the freeway lane-to-lane analysis. What we can do here is for a certain freeway facility, we can analyze performances. For example, freeways, speeds, or densities can be analyzed on a lane-by-lane basis. As mentioned before, the main idea is that depending on the origin and destination, you may pick a certain set of lanes on your trip. So if we look at this figure, for example, we have two different trajectories. One of them, the red one, if you're simply traveling through the entire facility. The second one in blue is a different OD pair. If you're entering the freeway through this on-ramp, but you plan to leave the freeway through the following off-ramp. So in that case, you are more likely to use the rightmost lanes, which have typically a lower speed. So your trip is likely to be a little bit longer compared to a person who is just traveling through and is more likely to use the leftmost lanes in the freeway. Then this is also implemented in the highway capacity software. So when you analyze a typical network like that, and let's say you're trying to analyze a trip between points D and H, you're going to model the urban streets separately, you're going to model the freeway separately, and then you're going to connect all these elements in the software. So we have this ability, and then the software is going to run all these calculations, look for occurrences of queue spillback, and convert everything to travel time. And the final result will be something similar to that. So between points D and H, the software lists every single segment that's traveled in the trip, in the sequence, and you can see for each one of them there is a computed travel time, and in the rightmost column the cumulative travel time, and by the end, the last row, that will be the total travel time of your trip. So you can do this for every single combination of origin and destination points in your freeway, and that's what we have in the new release of the highway capacity software. So thank you very much for watching.